All right, let's jump right in. We're going to tackle a massive question today. What is all of this everything actually made of? We're going on a journey, you and I, from the absolute smallest flicker of reality all the way up to the entire cosmos. We're going to build the whole universe from scratch, just using the basic rules of physics. So let's do it. Okay, so let's kick things off with a pretty wild idea. This quote really gets at it. The story of the entire universe is also your story. I mean, think about it. The atoms that make up your brain right now, they were cooked up in the heart of a star. And even before that, they were nothing more than tiny, random jitters in the fabric of space and time. It's kind of poetic, right? So if we really want to understand how everything gets built, from stars and galaxies all the way down to us, we've got to dig deep. We have to start at the absolute bottom floor, the deepest layer. So what is the fundamental fabric of reality? Okay, so this is where we have to throw out that old mental picture we all have, the one with empty space and little tiny billiard balls zipping around. That's not really how it works. Modern physics tells us it's a lot weirder. Imagine the entire universe is more like a giant, invisible ocean, and this ocean is filled with these fundamental fields that stretch everywhere, through everything. And here's the real kicker. Particles, as we think of them, aren't really things at all. They're not solid little dots. An electron, that's just a little vibration, a little excitation in the electron field. A photon, a particle of light, same deal. It's a ripple in the photon field. So everything you think of as solid is actually just a concentrated little vibration in one of these universal fields. Mind-blowing. All right, so we've got our fundamental building blocks, these vibrating fields. So let's climb up to the next level. How do these simple little ripples manage to build the incredibly complex world that we see all around us? It's actually this beautiful step-by-step assembly line, right? The fields vibrate and out pop fundamental particles like quarks and electrons. Then, those quarks get together, they team up in little groups of 3 to make protons and neutrons. And then, finally, electrons get snagged into orbit around them, and bam, you've got your first atoms, the Lego bricks for everything that comes next. But honestly, a universe with just hydrogen and helium atoms, it's a little boring. The real magic, the next giant leap, happens when these simple atoms start getting creative and building something absolutely extraordinary. Yeah, we're talking about life. So, just by following the basic rules of quantum mechanics, these atoms start linking up, forming more and more complex molecules. And eventually, you get these incredible structures like DNA, which can do something amazing: store information and make copies of itself. And just like that, chemistry crosses a line and becomes biology. The non-living has somehow organized itself into the living. It's a huge step. But the story doesn't stop there, not even close. The universe keeps on building, layer upon layer, stacking complexity on top of complexity. And it's all heading towards what you could argue is its most incredible creation of all. Over eons, literally billions of years, those single cells started working together, forming complex organisms. And eventually, this whole process led right here to the human brain. We're talking about a network of 86 billion neurons. And every single one of those neurons is connected to thousands of others. It's this incredibly intricate machine, and get this, it's all running on the exact same fundamental forces that hold galaxies together. And this image just lays it all out perfectly. It's like a cosmic ladder, right? You see the entire hierarchy of reality. You start at the bottom rung with quantum fields. They give rise to particles, which build atoms. Atoms build molecules, which build cells. Cells build brains, and brains, they give rise to consciousness. Each level just emerges from the one below it, creating something totally new and more complex as you climb. And this, right here, is the amazing part. The payoff to the whole story. Through conscious beings like us, the universe has figured out a way to become aware of itself. I mean, just think about that for a second. The stardust, the leftovers from the Big Bang, has organized itself into a brain that can ponder the very laws that brought it into existence. It's this incredible, beautiful cosmic feedback loop. Okay, so we've got this incredible, multi-layered universe. But what are the rules? What laws does it actually run on? Well, this is where it gets really interesting. Physics has handed us 2 amazing rule books. They're both spectacularly successful, but they're also completely separate. On one hand, you've got quantum mechanics.
This is the rulebook for the tiny, weird world of particles. It's all about probabilities and strangeness. Then, on the other hand, you have Einstein's masterpiece, general relativity. That's the rulebook for the huge stuff, planets, stars, galaxies. It describes gravity as this elegant curvature of space-time. And here's the thing. Both theories work perfectly. They're flawless, as long as they stay in their own lane.
So, what's the problem? Well, the problem is when you run into places in the universe where you need both rulebooks at the same time. When the world of the very big collides with the world of the very small. When that happens, the two theories don't just disagree. They give you answers that are completely incompatible. They break down.
And the battleground for these two great theories? It's at the absolute extremes of the cosmos. We're talking about places like the very instant of the Big Bang or the dead center of a black hole. Why there? Because those are the only places that are both incredibly tiny, which is quantum territory, and unbelievably massive, which is relativity's turf.
And this isn't some small disagreement. It's a fundamental conflict. Let's take the center of a black hole, the singularity. General relativity says it should be a single, smooth point with infinite density. Simple, right? But quantum mechanics screams no way. It says that on that tiny, tiny scale, space-time can't be smooth. It has to be a chaotic, bubbling, probabilistic foam. You see the problem? You can't have a smooth, infinite point and a chaotic foam at the same time. The math just completely falls apart. And that right there, that conflict, brings us to what is basically the holy grail of modern physics. The ultimate quest is to find one single, more fundamental theory, what they call a theory of everything. A theory that can unite quantum mechanics and general relativity under one roof. A single elegant rulebook that governs the entire cosmos, from top to bottom. So what is that final chapter? What does the ultimate theory look like? The honest answer is, we don't know yet. But finding it, that would mean we finally understand the complete story of everything. The entire narrative, from that first tiny quantum flicker, all the way up to, well, us. The conscious minds asking these exact questions. It leaves you wondering, right? What do you think that final law of the universe will really be?